Hello, this is a summary update to logarithmic pole model, how it was published first time on March 28th, 3 years ago. The intent of this video is both to improve in the quality of delivery of ideas and on the mathematical foundations of the model that is now based on a growing series of integers and practically an n-dimensional system at the basis, which is then reduced into a four-dimensional one that we are not directly looking at in this model, but of which we can see a three-dimensional projection of into our universe. I really got interested in the cosmological implications of logarithmic pole model in 2018 on summer vacation in Tuscany. I was stuck with analytical progress of the model, and to get some idea how to proceed, I wanted to simulate the initial state of the system in a four-dimensional grid. And since I had been simulating systems, gravitational systems during my studying years at the University of Oulu, I decided to apply those methods to sampling of a random distribution of points within a unity distance of the center of the system, and use just simple 4D Cartesian coordinates to begin with here. And what was observed then was the accelerations based on pairwise interactions of all pairs of bits that are the positive poles of logarithmic potential and nits that are the negative poles of logarithmic potential. And you can see the interaction rules for these poles down here in the middle of the slide. And on the diagram you can see outwards going accelerations above the zero level here, and the inward falling accelerations below it. And you have the radial distance from the center origo of the 4D system on x-axis here, and the unity is here. So the unity distance that is mentioned here in the diagram, it is a divider of the how the particles, or rather these poles, are behaving. And as you can see, nearer to the unity from the origo, the pit-nit pairs, they are kind of repulsive, but immediately the distance gets bigger than unity on the average, then pit-nit pairs become attractive. But the cloud of outwards accelerating nits that unfortunately are depicted here in the orange color, not blue. So these nits have gained a kind of potential impulse that gives them lift outwards. And what is noteworthy here is that there are also some pits that have the outward acceleration, and more accurate simulations would be needed to kind of truly see how this system evolves from scratch, because since the model nowadays is based on growing system of poles starting from just one pole, that is by bifurcation it's producing two, and then onwards we are adding to the number of the poles n-dimensionally, and we have a kind of squashing into 4 dimensions for reasons that I explained later on this video. We actually would have a system that is gradually beginning to grow, and within a very small space, and perhaps we have a different kind of proportion of these positive these bits that are expelled outwards, with the majority of nits that are then helping to create zero potential around the 4D origo. And this zero potential is practically a sphere shell, 3D sphere shell, and that is where our universe lies in this model. One of the biggest inventions of this model is that it actually gives you a reason for a constant speed of light. So let that sink in first. So you can actually calculate a speed of light and give predictions of its evolution along time. And since time is addition of new poles to the system, we have a kind of relative time, so that each step in time is a little bit smaller than the previous one in relation to the whole age of the universe. So when we calculate the speed of light, we make these observations. So we have core of bits in the system. Most of the bits are there. Only a small proportion of the whole number of bits is positioned on the along the zero brane. That's a 3D brane that is expanding outwards from the 4D core of the system, and most of the poles along this 3D brane are actually nits. There you saw that simulation showed it. Nits are expelled in large masses outwards, and that expansion is then preserved in time. There is an acceleration that we can calculate that is caused by the motion of the bit along this 3D brane, and so we wish to see that the acceleration outwards by centrifugal force is that is purely a geometrical effect, and here d is the 4D radius of the 3D brane. So the acceleration is v squared divided by d. And on the other hand, we have the acceleration of the n bits of the system, or actually when we think about bits, they are attracted both by nits and bits of the system. So we can take the whole number of all poles in the system and approximate its this kind of average distance calculated from any point on the 3D shell. We have the kind of averaging here, so we say that okay, on the average the distance to whatever pole we have in the system, be it at the center of the forces system or along the 3D cell. On the average, we have the distance d, that is the radius. This is exactly true for the practically most of the bits at the origo of the system, but then we should practically calculate analytically more exactly what is the actual medium distance to other poles along the shell. And equating these two, it means that there's no radial acceleration but only tangential movement of this bit. We can find that actually within logarithmic potential, that is a peculiarity of this kind of potential that we also observe in galactic rotation curves. There's practically this strange dependence that actually the velocity is, if the potential were to be exactly logarithmic, the velocity of orbiting bits here would be square root of number of poles within the system, and it is independent of the radius at which this 3D brane is located. This is a big discovery because we are looking for universal speed of light that is kept constant somehow, and within this model we actually find a reason for that constantness of the speed. And when we think that the bit travels along this 3D brane in our physical space, the bit can be traveling whichever 3D direction, and it is still going along this circular orbit in 4D coordinates. And as you can imagine, the velocity, since it's dependent on the square root of number of poles in the system, since number of poles is increasing constantly as time passes by, it means also that the velocity is very, very slightly growing along time. But it also means that in the very beginning of the system, this increase in the speed of light has been many magnitudes of in relative importance. From here we get into a very important point. So we know that the number of particles in the universe is around 10 to the 80, and in this model particles as we perceive them are like aggregates of bits and nits, and photons instead are 10 to the 9th power more in the universe. So since also photons are like dipoles in this model, so we can take kind of approximation of numbers of poles based on this particle modeling I have, and get a number of 10 to the 89 poles in the system altogether. Which in turn translates into square root of that, giving a velocity that is 3 times 10 to the 44, and we are using time units. That is each time unit is practically the addition of one pole into the system. Now the tricky thing that it might be difficult to understand. So if we think that the universal constant velocity on this 3D brane is that of light, then we equate that the v is equals to c, that is 300,000 kilometers per second. And based on that, we think that, okay, we have this many steps, unit distances that are covered in one time step. And since in our physical universe we use meters per second, we can equate that the unit distance that is valid for exactly second as a time unit is 10 to the minus 36 meters. And we are within one order of magnitude from the Planck distance, that is known to be 1.62 times 10 to the minus 35 meters. And here you see that this implies exactly fixing second as time unit for the model. And as I said earlier on, we could actually get a bit different approximation for this medium distance radius here, taken from a pole along the 3D plane towards whatever poles there are on the far side or near side of the system. So it might be that we actually get even closer to the Planck distance using this formula here. So this is very promising from the evaluation standpoint of the model. So to illustrate that the attraction and repulsion rules between poles are not totally arbitrary, it is now a good moment to introduce you to the acceleration graphs based on the logarithmic potential between pairwise potentials of various combinations of bits and nits. We are always talking about a 4 distance, and it is presented by D. So we have the 4 distance between two pits first, and the potential is logarithm of D. And we can see that the accelerations then as a negative derivative of the distance between the poles, you get also negative acceleration. That means that the two bits are attracting each other and at all distances. Then when we take two opposite signed poles, nit and pit, we can see that there's a practically absolute value of logarithm d in between them as a potential function, and is shown here. And you can see that the acceleration is then discontinuous at the bottom of this potential well at unity. So we have outward pointing acceleration. So the opposite signed poles, pit and nit, have a repulsion at distances smaller than unity, and then this is switched into an attraction at distances bigger than unity. And as a last case, we have a nit-nit pair, and there we have the situation that the pair potential is minus logarithm d, and shown here, and its negative derivative shows and positive acceleration, meaning that two nits are repelling each other and removing farther away from each other if there are not other poles involved in that context. And this is a repulsion that is infinitely far away as well. So this is something that keeps on going the system's expansion when additional needs are introduced into it. And especially this is true for the 3D brain that is mostly consisting of nits, and instead when the aggregates of poles are concerned, nits are kind of bound to pits very strongly, and whenever there is just one pit in the aggregate, and from 1 to 3 nits aggregated into it, then that aggregate in itself has the speed of light, as we derived in the previous slide for a single pit traveling along the 3D brain. So the practical application of the acceleration rules we just went through is basically this. We have aggregates of poles, and they are representing various particles. This is practically a 4-dimensional structure, symmetrical structure. You can think that these 5 nits that are depicted by blue dots, they form a pentatope. So you know the triangle and tetrahedron, the next one in 4 dimensions is a pentatope. So they are symmetrically positioned in respect to the center of the system, where there are instead 5 pits that are, as you saw, there is no limit to the attraction, though the accelerations are inwards. And unlike in gravitational potential, and you perhaps know the 3-body problem, there is no such a slingshot effect as you know from gravitational potential. Logarithmic potential behaves very differently. I'm hoping to add a separate slide about that later in this presentation. Anyways, you can find from literature that logarithmic potential works as a perfect thermostat, so it absorbs any kind of perturbation presented there. So practically these pits are located very closely by here, but since this model, logarithmic pole model, is not limited to 4 dimensions, but it is actually 4 dimensions is just a projection of aggregates, and where we operate usually when we are dealing with bigger distances. At smaller distances we actually go to the higher dimensional structure that allows to collocate all these bits very nearby here, kind of at straight angles of the 4-dimensional structure that the needs are occupying here. So what you can see here, these are this kind of list of coordinates where these various needs are positioned, and we have the x, y, z, that's a 3-dimensional part, and then we have a transverse component here, and you can see that the transverse component is 1.78885 for this need here, and this distance here is exactly the same as a combination of these coordinates here. You can calculate 1 to the second plus 1 to the second plus 1 to the second plus 0.447 to the second, and you sum them up, take the square root, and in 4-dimensional you can find that you obtain this same distance. So those nits are equally far away in 4 dimensions from the central point here. And central point is at 0, 0, 0, 0 to help the calculation, makes it simpler. I had on Excel a big sheet that is calculating the potential values here, and I locate nits, and there's this minus logarithmic. We could in citations we could call it charge, but that is not correct because it's not nothing to do with electric charge. And we have then the positive ones 5 at the center. In logarithmic pole model, this structure here represents proton, and how to calculate the electric charge of this structure and its relative mass, we get to that later on. Those of you who have studied inflationary theory, you know the Mexican hat-shaped potential, and we have this present within the particles here. This is valid for also other types of particles like electron, and for Higgs it's even more symmetrical because we have one more dimension added to the model, and when then viewed along the 3-dimensional brain, then we see the shape of the potential even more symmetrical in that sense. And since early on we had this simulation of early phases of the system, we can imagine that we have had where there is a large concentration of bits and nits, that they are kind of very randomly shaped zero potential running across that chaos of poles, and then this shape of potential is there driving the outwards expansion of those poles, so that they are tending, when bit-nit pairs are concerned, they are tending to arrive first at the unity distance that is kind of attractor for them. And it also means that there's this kind of symmetry breaking happening at that point, because there's no going back to the original configuration of the poles from that original chaos. And perhaps one more observation here. So these aggregates, when they are this symmetrical, they have a possibility to kind of oscillate radially, and this oscillation is totally symmetrical. So actually, when we look at the system that is in kind of minimum at unity distance between positive and negative, between bits and nits, we would have here like unity, and all the distances are then equally at the same proportion. They are then shortened from 1.79 to unity, and then also all these coordinates are equally decreased in the same proportion. On this slide there's lots of information. So first of all, what we are looking at here are the aggregates of poles that have only one bit, and it is the red end of the line segment. The blue end is the nit. So here, for instance, to the to the left we have an aggregate where there is just one bit at the center and 3 nits that are in a triangle formation around it, and there is a possibility of this system to extend radially, and we'll look into that soon after. First, I wish to explain the lines here. This orangish line is the 3D brane, and it accommodates X, Y, and Z axis in our physical space, and there is the 4th dimension, that is radial dimension of the 3D sphere shell. And what is also here good to notice is that when the system we were looking at the early expansion of the system, the nits tend to position themselves outwards and pitch inwards in this expansion naturally. So when we are looking at the zero brane here, and the outside is here the upper part from that zero brane level, we should have there an excess of nits, and where these structures with kind of excess of nits in respect to pits, here we have 3 nits and only 1 pit. If they were to positioned below the zero brane, it would mean that it's kind of contrary to the expansion model we earlier showed. So their kind of natural asymmetry is that they are positioned on the upper part, outside part of this zero brane. And the same is true for this another combination where we have a kind of dumbbell structure and only 1 pit, and on the opposite sides from it there are 2 nits. And also the dipole. This is where the model has evolved from what was presented 3 years ago in a separate video about the neutrino oscillation. So what I have come to understand is that structures that are positioned at right angles to the zero brane, they have relevance in terms of electromagnetic interaction and gravity, while here when positioned parallel to the zero brane, those interactions are at least at short distances they are missing. So this is one big difference, and when later on I will present also the 3 generations of fermions, and also go towards the quark structure, we can see how they are so parallel to this neutrino structure, but it is only the spatial positioning in respect to 3D brane that changes their interactions. And now we here I state that following the attraction and repulsion rules, one can judge with for the aggregates of nits and bits are stable, and how they are positioned regarding to zero potential. So you recall that the logarithmic potential, the 0 point of the potential, is at unity distance, and this universal zero potential is here. So it is aligned with this kind of structure when all of these poles are at unity distance from the brain. This is also true here, and internally within the aggregate we can make comparisons. The dipole that is positioned this way, it is the photon, and there is also a dipole positioned that way, and that is then one of the neutrinos. There are 3 neutrino generations here. So we can look at the internal accelerations that a component of this aggregate is experiencing at various distances of extension of that line segment that connects bit to nit. So first, the simplest case we have here with orange tinge, the one case for photon, and also the case for this neutrino that has only one nit. So this nit pit dipole, but like photon, but it's different spatial configuration here. And when you go from distances above unity, you see that there's a negative acceleration. So it means that there's an attraction force between the components of the dipole, and when you go to the 0, practically there's a kind of discontinuity in the acceleration, and you at the shorter distances you get the positive acceleration. That means there's a repulsion between the components, and this would certainly not work if there were not any kind of inertia. So we have to introduce certain kind of inertia, but it is not associated with mass, but it is associated with the charge of the poles that I call bank. And so bank inertia is something that is kind of here gaining kind of inward acceleration, and then inertia is pressing the dipole inwards, but there is already an outwards acceleration that then in the end will reverse the movement of the component in this aggregate. So this is true for other aggregates as well. You can see that for dipole the situation is kind of specular in respect to the unity distance, while in the case of 2-nit neutrino, we have a situation where actually when you come from distances bigger than unity, you have inward acceleration that is in size here. You can say it's -1/2, but when you go to distances smaller than unity, there is an outward acceleration that is 3 times as big. So these neutrinos are kind of more stringy in their composition. So there's kind of a hardened bounce outwards from this structure. So it is not symmetrical respect to unity distance. And then we get to the third neutrino that has three nits in a triangular composition around the one pit. And this is also a reason for neutrino oscillation. Why? Because you can see that there is no acceleration at all, and neither inwards or outwards when the distances between nit and pit here radially are bigger than unity. So this structure is totally free to expand without limit once it kind of is concocted in some contexts. When you create a kind of this kind of neutrino that those from outside pressure or outside acceleration cause these three needs to go around one pit, then in that case you have a situation where the outwards acceleration is even stronger than in the case we just looked before. And once the structure has expanded beyond the unity distance here, that the radius kind of from the pit to the nits is above unity, then the accelerations cease and there is no kind of returning acceleration that would begin to reassemble this third generation neutrino. And since we are operating in an environment where we have an excess of nits, and there will be probably also like free nits floating freely here in between along the 3D brane, there will be some oscillation between these configurations of with 3 nits, 2 nits, and 1 nit. There will be oscillation between these ones, and that is the origin of neutrino oscillation. The same is not true in case of structures that are kind of transversal to the 3D brane. There we have some other consideration to be done, and we will look this more in detail when we go to the structure of proton and neutron and look at the quark composition. And perhaps one more consideration to this slide, you can see that photon is positioned so that the distance is 1/2 both sides of the brane, while the neutrinos are positioned at a unit distance in all their components. It also means that there is extremely weak possibility of interacting between these luminal aggregates that are traveling following their pit, that is the red point here, at a speed of light, and they are not kind of at the same level of from the 3D brane, so they are not, their cross section is really minimal. So the biggest takeaway from this slide is probably the fact that if you look from the point of view of a nit to this triangular neutrino, you see that the pit is attracting at the same, the acceleration towards the pit is the same as the sum of repulsion from the other far side, two far side nits. So there is some like net zero acceleration when we are talking about distances bigger than unity in this aggregate. At the smaller distances, is that this acceleration in its direction is inverted, and it becomes repulsive between nit and bit at the distances smaller than unity. So this is only an appetizer about the other particles we are going to handle and discuss later on. So to the right hand side now we depict the 3D brain with this orangish level here, and to the right hand side we have bit and nit of the photon, and to the left hand side we have instead 3 nits in a triangular composition, and 3 bits at the center of this aggregates, and this aggregate is electron. And you can see that there is a way to calculate the relative charges of these aggregates in making a bipartite graph, where on the other side you have the photon, on the other side you have the aggregate particle, and you calculate the attracting parts of interactions, and then subtract the repulsing ones. So you get this coefficient here, 6, that is corresponding to electric charge 1 fundamental charge. And when we are then going to see the quarks, we will find out that there are these composite parts of bigger aggregates that have only one positive bit here. So we will get then the coefficient that is 2 and 1/3 of the fundamental charge, and then there are also those quarks that have 2 bits at the center, and they have the coefficient 4, and that is the 2/3 of the fundamental charge. The signs of these charges, at this point I only say that there are sufficient degrees of freedom to get them in correct order. When you put together various quarks, then you can get the correct electric charges, and also you can see which quark compositions are possible for proton and neutron. I have been lately working on this a bit further, analytically on paper, and will present the results at some point. Just to additional note that to quarks generations you have kind of you begin with 1 bit and 2 nits, and adding, every time you add a nit, the coefficient actually remains the same, because you're adding both one attractive and one repulsive interaction. So there you find, through that reasoning, you can find the quark generations. And perhaps on the previous slide you saw the equipotential lines drawn for electron internal structure in this triangular configuration of nits around the PT center. And here instead is what I found last year about the orbital stability in logarithmic potentials It is called three-part hypocycloid, and apart from the circular orbit, this is the simplest trajectory in a logarithmic potential, and this is just another additional evidence that I'm onto something with these structures, that logarithmic potential is creating for particles in aggregates. So I go observations first. There is this energy range of photons derived from the biggest of all time gamma ray burst in late 2022, and what we can see there is that the median of energy in this section of observations that contains most of the photons is at 1.62 tera electron volt, and on 2nd of May 2021 I made a prediction of a new particle to be found at 13 times the energy of or mass of the Higgs boson based on the logarithmic pole model, and with present knowledge of the Higgs mass, that prediction hits exactly 1.626 tera electron volt, and I'll explain in the next slide a bit more about the relative masses, how they are originated, how they are calculated in the logarithmic pole model. So this is an alternative view of how to combine mass to the particle models, and models that on the other hand they give also prediction or actual electric charges for these particles. And keep in mind that the model here doesn't really have practically free parameters. It is only kind of anchored to the mass scale at one point for, we'll say, neutron, and then masses of the other particles are obtained by calculating from there, and you also obtain an inner structure for those particles.
There are various points to be made on this presentation taken from 2 years back video. First of all, the relative masses of the particles are obtained from factorials. I needed system how to obtain the big scaling factor of between the masses of various particles, and multiplication seemed a way to get there rather than summing something less potent terms. Already earlier it had kind of caused interest to have this ninefold mass of proton and neutron with respect to muon. So I decided to study further possibilities with these integer factors. And it was a really nice discovery to find out that actually Higgs particle, when it was discovered, it had this 11 times 12, that is 132-fold mass in respect to proton and neutron. So I decided to pursue this program further and make also a prediction a couple of years back when I kind of discovered that these factorials can be presented also through this integration from 0 to 1 of higher powers of a logarithm function. The fact that the integration is taken for the interval from 0 to 1 is especially interesting because in the stability model of these poles, if you put pit and nit together, their distance will be kind of exactly the unity distance in a stable situation when there are no disturbances to that system at the dipole. And instead, for instance, how the model presents the neutrinos, there is one positive pole pit at the center, and the fact that there are two or three practically nits around it means that the distance is exceeding unity because there are more repulsions than attractions, and it will cause the situation where there is no potential mass that can be attributed to the neutrinos from based on this model. Alternatively to the factorials, one can imagine the number of ways of going through the aggregate of poles, starting from one vertex and going through all the other vertices without revisiting any of those. So the ways, different ways you can do that gives exactly the factorial of the number of poles involved in the aggregate. And in case of neutron, there are 6 nits and 4 pits. So this surplus of surplus of nits means that it has the possibility of decay, and instead, in case of proton, there are 5 of each, bits and nits, and it is a very stable structure. And then let's go to the prediction made 2 years ago. So I predicted that there would be a 13-fold Higgs mass particle found, and it was based on idea that indeed the number of poles, when increased in the structure, they kind of give rise to these higher masses. And based on the Higgs mass known a couple of years back, I got the estimate of this 1613 giga electron volts as the mass of this predicted particle. But meanwhile, now we have had updates on the Higgs mass, and now the prediction would be for the 13-fold mass 1626 giga electron volts. So what I found instead from the gamma ray burst, that is the biggest of all time, practically discovered last year, there is this segment of energies from gamma rays arriving that has been identified. And in that segment of energies, the energy median is exactly 1.62 tera-electron volt. That is pretty near to the values predicted. And since the origin of the system is a collapse or into a black hole of neutron stars, probably, then those are also the conditions where this kind of particle could be created. And why this? Because the system, the model in itself has no limitation of dimensions, but the fact that we are living in the 4 dimensions, it's a kind of consequence of Lagrange's theorem of sum of 4 squares, and it means that if you have more than 4 dimensions, you kind of find a shortcut to connect the poles through a 4-dimensional squashed dimensionality, and this already is true for Higgs. And since Higgs has 6 nits around the core of bits, it means that it is employing already 5 dimensions completely. And to have a situation where you have even higher dimensionality of the particle, it means that particles is even short-lived, and practically here we are talking about a 6-dimensional temporary structure, composite like aggregate of poles, where there are 7 nits around the core of bits. And these kinds of conditions very plausibly can be created only in extreme conditions like a collapse of a neutron star into a black hole.
Next time I hope to get more into detail about the mathematical origins of the logarithmic pole model. Here we visualize the adding of poles into the system, and we start with the point and then the line segment and a triangle. And actually when we consider of edges that are of equal length between these points, we don't really have kind of, without reference to any external measure, these all cases up to a triangle are equivalent. However, when we add the fourth point to the system and into the simplex structures always, so then there is a difference between the left and right-handed system, but that difference only exists when we take into consideration the ordering of these points. And practically what this model suggests is that we have a binary choice at each added vertex, and once we have the system kind of collapse into one of or the other of those values, then the other part disappears as a counterfactual. From a logarithmic pole model point of view, only based on like a consideration of the accelerations, the logarithmic function in itself is obtained from the simplicial structure, because it gives the coefficients used in a series expansion of logarithmic function, and therefore we are not introducing anything from outside of this mathematical construct to obtain the logarithmic pole model. It also means that in the very beginning of the model evolution, when the system is small, we only have at disposal the first few terms of series expansion, so we are not exactly talking about the logarithm in a mathematical sense yet, so we have only a few terms involved in the beginning, and actually this has implications to the calculation of mass, relative masses of particles under this model, when we have only a few poles involved in the aggregate of a particle. So this is something that is very interesting, because we have kind of totally mathematical foundation of the model, and we don't have to introduce anything from outside this simple mathematical basis. then the presentation can be further taken into the matrix one, and we kind of start from the realization that there is diagonal n times n unity matrix that describes n minus one dimensional simplex, and in itself it has no ordering of these vertices, but then with the matrices we create all the possible rational numbers based on the number of vertices we have at our disposal, and the relative ordering of those poles then becomes, of these vertices becomes important to construct the rest of the model, and we will see why in the following few slides. Actually, perhaps in this video we don't go into depth, but just present some interesting detail. So when we go into the geometry of the model, we are also interested on something that we usually tend to think as a constant, that is the value of pi, but instead in this approach we construct also a kind of value for pi that is dependent on the size of the system we are looking at, and we can do this through Wallis product. So the value of pi is Wallis product multiplied by 2, and you can obtain the values here. You can see the first few steps how the value is evolving. So we think that the geometry of the system is kind of evolving and compensating, and we know that there are kind of relations between exponential function and value of pi that are rather fundamental in mathematics, and since we are kind of obtaining the logarithmic function from the same construct going through the simplicial structure, and that is a kind of inverse function of exponential function, then we are rather in going into depth of into mathematics, and this is certainly a nice thing to study further, but I only have so far tried to get those interesting details that may be useful in developing this model further. And to conclude this video, here is the last thing about the mathematical foundation I wish to bring forth to you. So you can think about this series of vertices as a one-dimensional succession, where you in the end you make the ring by joining the last point back to the first one. So you get these multipliers for Wallis product, this kind of you can graphically see that, okay, you take I go through the multipliers here in this column now. Let's see this column now, and there's the first step. This is okay from the time glass. You take twice, and there you get to the next time glass here, and you take 2/3 of the length to get here, and then from the next time glass you take this is like a 4/3 respect to the 1, 2, 3. Okay, 4/3. You go to the next one here, and then 4/5. This the kind of destination is always described in terms of this reference point that is here. We have like 1, 2, 3, 4, 5 steps, and this is 6/5, okay, and so on. And going this way through the whole table and going forth, we can make a kind of a trick here. So we think this growing structure as a ring. So there's the last leg of this street to get back to the beginning, and what we wish to see here is that, okay, perimeter of this thing is then 1, 2, 3, and 4. And suddenly to take the first, join the first and last step here with the equally long leg, it means that, okay, we are already going towards a structure that's rather definite. And in case of if all these legs are equally long, I think what we arrive to is automatically, in this case, we come to the tetrahedron with 4 vertices, all combined with equally long legs. And we can go and see here on the right hand side that the in case of 4x4 matrix, we think that, okay, perimeter length is 4, and we have on the other hand, we know the equation for the perimeter length is 2 pi r. Okay, so what we think is that 4x4, we take first we take 2, okay, and then we take the radius, sorry, no, we take 2 times twice Wallis product, so this is like a value of pi for 4x4 matrix. It's taken from here, and we multiply it by r to get the perimeter 4. And we calculate a kind of more fundamental radius that I can't relate to anything we know at the moment. What does it mean? This is a kind of esoteric thing. Please chip in if you have any idea what this means. But I see that this radius is kept constant for always 2 steps, for 2 consecutive steps in evolution of the system. And I have a kind of idea what this could mean, but I let this as an appetizer for the next video and go deeper into the mathematical things then. I hope this video was interesting, and every kind of feedback and comments are very welcome, since the model is has been under rather intense evolution last 2 years, and so I expect that there might be growing interest if somebody first gets to look at some of the things that are rather spectacular, considering that there are no kind of free parameters into the model. So this is something that is made from scratch. Thank you.